All right. So where are we? All right. Everyone able to see that in class?
Yes.
All right. Good. So we got to talk about function notation. We've been talking about functions, domain and range, when we have a function based on a diagram. So sometimes we got to talk about how we name a function, right? Functions are going to be different kinds of equations. We mentioned that. So some of the equations we can use will be a linear equation, y equals 3x plus 2, a quadratic equation, y equals 5x squared minus 6, cubic, quartic. Quartic just means we have that 4 up there. Don't worry too much about the types of equations. We'll talk about some of these as the year goes on. But just know that equations all have in common this y equals thing. In function notation, we're going to replace the y equals with this notation here, this thing here. It's called f of x. That's what this is. These are the words that go with this expression. F is a function of x. Y is a function of x. Right? This just tells us instead of y, right, remember the last one we had was this very first one, y equals 3x plus 2. Well, now we can write f of x equals 3x plus 2. We replaced y with f of x. It just means that this is the y we get for some x that we put into here. F is just a name of the type of function that we're looking at. In this example, it's saying to find y, we use the function that is named in terms of x. Sometimes we'll be looking at more than one function at the same time. In this case, we can use any other letters, right? They're not always going to be f of x. We can have g of x, f of x, g of x is some other function. Any number of functions, f of x, g of x, h of x, k of x, etc. Just means that if we have two different things we're looking at the same time, we have to call them something different. They both can't be f. So sometimes we need to use this to evaluate a function. This is something we've been doing already. You put a number in to the function to get your y. We put some particular x in to find a y value. So let's look at that first function we had. F of x equals 3x plus 8. And I would ask you to evaluate f of 3. This just means that we're going to plug in the number 3 to whatever that function is. So if f of x equals 3x plus 8, f of 3 is equal to 3. Now here, we replaced x right there with 3. Do the math in there. 3 times 3 is 9. 9 plus 8 is 17. What this tells us is that when x is equal to 3, the y value we get, our output, this is our input, x, output y, y is 17. Or that the ordered pair, 3 comma 17, is a solution to this equation. It's really, really pretty simple. So, how are we going to do I have the end? Yes, I do. So I don't want to do that. Let me put the screen up for a second. All right. So you guys should take out a piece of paper right now, the three of you in class, and see if you can figure out these two. And then we'll go over those. So I'll give you a minute or two to do this. It's going to be a really short lesson today. I'm not going to give you very much to do over the weekend. I just wanted to get this little piece out of the way this week as we move on with functions. So doing what we just did, see if you can find f of negative 3 in this equation. That just means we replace x with negative 3. And here we replace x with 5. So I'll give you like 2 or 3 minutes, I guess, in class to do this. I don't want to go back to the screen where I can see you because I'm recording this for the people at home, so I don't want to show you on screen. All right, this is crazy me sitting here like this. All right, if you're at home watching this, hopefully you tried this and you got your answers. You can pause the video at home. But for you guys who are sitting here with me now, let's take a look at this. F of x is 4x minus 8. F of negative 3 means we replace the x with negative 3. Negative 4 times negative 3 is positive 12. 12 minus 8 is 4. So f, this is how we would write it. F of negative 3 is equal to 4. And that just means that we have an ordered pair, negative 3, comma 4. That's a solution to this equation. And on this side, just a little harder because we had that squared term, right? So just be very careful when you're doing that. We're replacing x with 5. 5 goes in where x was. 5 squared is 25. Negative 4 times 5 plus 1. Negative 2 times 25 is negative 50. Negative 4 times 5 is negative 20 plus 1. Negative 50, take away 20 plus 1 is negative 69. So our solution here would be, that was coming out horribly, negative 69. Now, this one's a little more difficult because we got this cube term, but you have calculators. The calculator will do this for you, right? So f of x is 5x cubed. I want to find f of negative 8. Negative 8 cubed. This is where you would put that in your calculator. How would we put that in the calculator? Let me see. Let's see if we can see this. View. All right. Now, I know this calculator isn't exactly the one that you have, but I just want to show you that you can use your calculator to find this number. Whoops. Make it a little brighter. All right. So you would put parentheses, negative 8, close parentheses, caret cubed, and that's where we get negative 512. If we go back to our problem, that's exactly what negative 8 cubed is, times 5, negative 2560 plus 1. So f of negative 8 is negative 2559. In this example over here, it's just a decimal. It's 16x squared is our function. We need to plug in 2.5 squared. 2.5 squared is 6.25 times 16. We get exactly 100. All right, so find each value if f of x equals 3x plus 2, g of x is negative 2x squared, and h of x is equal to negative 4x squared minus 2x plus 5. For those of you at home, I will send this as an attachment so you have these problems for you in class. I'm going to stop recording right now. And that one.